Okay, so here we have a question that relates to, it's typically referred to as a system of equations. At least that's how I'm going to deal with this. That just means that we're given two relationships, right? And they're right here. We add them up, or excuse me, we examine them together in a system, we're able to solve them. We're told that a store has a total of 108 staff members, or people working there. We're also told there are three times as many full-time staff as part-time staff. So how many of the staff are in each category? So that tells us there are two types of employees. Let's call them X for full-time and Y for part-time. We know, or I guess we're assuming here that that includes everybody, right? The full-time, part-time staff members that works at the store. So when we say that there is a total of 108 staff members at the store, that means if we added up X and we added that to Y, what would that equal? Well, that's all the full-time and all the part-time employees. That would give us 108 staff members. But then we're given a second equation, right? We're told that there are three times as many full-time staff as part-time staff. So part-time staff is Y, and if we think about how many full-time members are, we know that whatever the amount of part-time staff members there are, if we take that and multiply it by 3, what we get are the amount of full-time staff members. And maybe you wanted to reverse this. Maybe you wanted to say 3x equals y. Just test it out with a simple example. Let's pretend that there are 10 part-time staff members. Well, then how many full-time staff members would there be? Well, 3 times that, right? So that means that you take y and multiply it by 3 to get the number of full-time employees, right? Because y is 10 and 10 times 3 is 30, and that would be x in this case. So if you examine a formula and break it down to a simpler example, I think it's a little bit easier to see what the equation would be. If you kind of reversed it and you try to say, oh, well, it's 3x equals y, you can see why this would be incorrect. Because if y was 10 and you try to solve for x, right? Solve for x here, you divide by 3, and that means, well, 10 divided by 3 is just 3 1/3. That x would equal 3 1/3. And what happened there was that the amount of full-time employees would actually be 3 times less, right? Because to get the amount of part-time employees, y, you have to multiply x by 3. So y is, in effect, larger than 3. So this one doesn't work here. And you can test it out with any number that works for you. But now that we have this system, what I would do, my strategy would be, okay, if 3y equals x, that means instead of x here, right, these are referring to the same x's and y's, I'm going to plug in this, 3 times y. So what happens now is that instead of x, we have y times 3. I'm going to write 3y plus y equals 108. This is referred to as substitution. And here now, we add 3y and y to get 4y, and that equals 108. We solve for y by dividing by 4 on both sides, right? Divided by 4, divided by 4. Here these 4's cancel out. And now if you have 108 divided by 4, that's just 27. And the way I solve that in my head is 4 times 25 is 100, times another 2 is 108. So 25 and 2 is 27. So the number of part-time employees is now 27. And the number of full-time employees, well, x is equal to 3 times y. So the amount of full-time employees is 27 times 3, and that equals x, which equals, well, 3 times 2 is, or 3 times 20 is 60, and 3 times 7 is 21, or 81. So that's altogether 109 people, right, working together. Okay, so I hope this helped, setting up a system of equations and then using substitution. Thanks.